Okay, so hello everyone. Continuing with our refresher course, it is session 3 today. If I quickly revise what we have discussed in session 1 and session 2. So in session 1, we mainly talk about basic concept of object-oriented programming. Okay, like what is object, what is class, what is encapsulation, what is data hiding or abstraction. Okay, what is inheritance in brief and what is polymorphism in brief. Okay, how an object-oriented program should be written, how object communicate with each other, what kind of methods are there in the class. Okay, and in brief, we discussed the access specifier, private and public. All right, that was like very core concepts of object-oriented programming without going into much details into the implementation of those concepts. Okay, on next day, that is during session 2, we mainly discuss arrays, strings, vectors, packages. Okay, now these concepts we discussed with regard to Java programming language. So how to implement the concept of array, one-dimensional array and two-dimensional array in Java, how to declare array, how to create array, how to initialize array, how to access individual elements of the array. Okay, similarly, we discussed the concept of string using two predefined classes called string class and string buffer class. Okay, we also discussed the concept of vector, which is very similar to array with certain differences. So, which is available in util package. Okay, we also discussed the concept of package at the end, where we try to group all the similar classes together using the concept of package. And we discussed that there are two types of packages like predefined Java API package and user-defined package. So if you want to create user-defined package, then how to create package, how to put classes into that particular package, and how to maintain the directory structure. These are the things we discussed in session 2. And with regard to package, ultimately we discussed there are total 4 types of access specifiers. And I said one of them, that is a protected access specifier, will be discussed when we talk about the concept of inheritance. But otherwise, we discuss private, public, and default access specifier with respect to the concept of package. Okay, and we discussed that packages give us very good control over what particular thing should be visible outside the package, within the package, and only to the class. All right, now fine. So today, starting with session 3, we'll be talking about more, you can say, slightly difficult concepts in object-oriented programming and how these concepts are implemented using Java programming language. Okay, so starting with inheritance. Okay, shared functionality or functionality sharing. Okay, what is inheritance? Let us take an example. Okay, consider that I have a class called student. Okay, so as you can see, public class student. I have certain instance variables like name of the student, gender of the student, birthday of the student, and there is a grade vector where I am storing various grades earned by the student. From that grade, using a method, I am calculating GPA. Okay, so there is a method called GPA, get GPA will return the GPA, that is grade point average of the student. And finally, there is one more method, get age. This will calculate the age of the student from the birth date available. Okay, so this is student class. Okay, fine. It must be there in some application which is related to educational institute. Okay, now look at another class. Okay, now there is one more class in my application called professor. Okay, so public class professor. Now I have certain instance variables, name, gender, birthday, and list of papers published by that particular professor in his or her domain. And then I have citation count as a method which returns citation count of that particular papers. And finally, I have another method called get age, which returns the age of the professor. Now look at the two classes. Again, if you look at the student class and professor class, name appears in student, appears in professor. Gender appears in student, appears in professor. Birthday also appears in student and professor. Okay, only difference in instance variable is here I am storing grades of the student and here I am storing papers published by the professor. And similarly, even in member functions, methods get age here as well as here. Only difference is here I have citation count and here I am calculating GPA of the student. Okay, there are so many common things between two classes. Okay, when this type of common things occur, when this type of overlapping things occur, we can use something called inheritance. What I can do is the commonality between these two classes can be represented with the help of more general class. Okay, I can say that ultimately student is a person because these characteristics, name, gender, birthday, okay, age of the person is more common to person rather than student. Similarly, name, gender here again is common to person rather than professor. What is specific to student? Student earn grades. Student get GPA. What is specific to professor? Normally professors, they publish papers, they have citation count. Okay, so this special thing of the student, that is grade and GPA, this special thing of professor, papers and citation count should be specific to these two classes. Otherwise, the remaining common thing can be represented with the help of more general class a person. So what I will do is, I'll create public class person. Now the common things in the student and professor, that is name, gender, birthday, and get age method, I will write here. And then from this, I will create two subclasses. Okay, as soon as I create subclasses, this existing class person becomes superclass. Okay, so in terms of Java terminology, the class from which you create a new class is called superclass. The class that you create from some existing class is called subclass. Okay, there are other ways to define this term, like parent class, child class, base class, derived class. Okay, but in terms of Java terminology, we'll be using the term superclass and subclass. Okay, so this is a subclass. As you can see now, a special way I'm creating the class. Public class student extends person. Okay, so here extends is a keyword and it specifies that I'm creating student class from person class. What is the meaning of extends? Extends means that it is a more specialized version of person. In other words, whatever characteristics a person has, all those characteristics a student also has. But apart from that, student also has something more specific, which is nothing but the list of grades and GPA. So I say that student is extending the capabilities of person. Person is a more general form, student is a more specific form. Okay, same way, then I create class professor. Again, I write class professor extends person. So again, we can say that professor class is extending the capabilities of the person class. Okay, such a way that all the characteristics of person also available in professor. In addition to that, professor has its own specific things, that is list of papers and citation count. Okay, so this concept where you create a new class which extends capability of existing class is known as inheritance. Okay, any programming language will be called object-oriented programming language if and only if one of these conditions, that it has to support inheritance, is satisfied. It has to support inheritance. Okay, so without supporting the concept of inheritance, a programming language cannot be called as object-oriented programming language. All right, fine. So this is a very, very useful and important concept as far as programming languages are concerned. All right, so let us talk more about inheritance in detail. So for like from here, you get overall idea that Why we require inheritance? So whenever there is a set of classes such that we have many common things amongst them, then those common things we can put in a more generalized class, and from that generalized class we can create the subclasses such that subclasses extend the capabilities of the generalized class. So generalized class will be called superclass, and more specific classes extending that capabilities of the superclass are called subclasses. All right, now let us dive into more details of inheritance. Okay, is a relationship. Okay, if I say carefully now so far we were saying that student is extending capability of person class, or professor class is extending capability of person class. Okay, I can say that there is a relationship is between superclass and the subclass. Okay, I can say like this: student is a person. Similarly, I can say that professor is a person. Okay, if I take another example, let's say it is for some company, you are developing your application for some company. So company may have an employee, company may have some manager who is handling or managing particular department. Okay, and if I list the properties, the instance variables of employee and instance variables of manager, again I will find very common things. Okay, so I can say that a person can be extended as employee, a person can be extended as manager. Okay, you can see it like slightly in a different way. You can also say that manager is also an employee. Okay, you are correct, manager is an employee. So in that case, I will declare employee as a superclass and manager extending capabilities of employee and become subclass of employee. Okay, so in this way, according to requirement and according to the logical design of your application, you can create a superclass, and from that superclass, as required, you can create subclasses. And the relationship that exists between superclass and a subclass is known as teaser relationship. Okay, now mainly we can divide inheritance into two categories. Single inheritance. Single inheritance means a subclass is derived only from one superclass. Whenever a subclass is derived only from one superclass, it is known as single inheritance. Okay. Second is called multiple inheritance. Now, what is multiple inheritance? Sometimes it is possible that one class has capabilities of more than one superclass. Okay, one class extends capabilities of more than one superclass. So now in that case, subclass is derived from multiple superclasses, and whenever a single subclass is derived from multiple superclasses, it is known as multiple inheritance. Okay, so there are two types of inheritance. Actually, people divide inheritance into various categories like single inheritance, then hierarchical inheritance, multi-level inheritance, single level inheritance, multiple inheritance, and hybrid inheritance. Okay, this is the entire list what I just said, but basically they all are coming from single inheritance and multiple inheritance. Question is whether you are creating subclass only from a single superclass, or you are creating subclass such a way that it is extending capabilities of more than one superclass. Okay, other forms like single level, multi-level, hierarchical, or hybrid inheritance, they all are created from these two, single inheritance and multiple inheritance only. Okay, so basically we'll be talking about single inheritance and multiple inheritance. Now, since we are talking object-oriented programming with respect to Java, Java has a restriction. It does not support multiple inheritance. Remember very well, in Java, you cannot create one subclass from multiple superclasses. Okay, why not? So for that, those who know C++ in detail, they might have studied that whenever you create or whenever you implement multiple inheritance, there is a chance of ambiguity. Okay, in simple and in short, in like brief, if I explain, let's say there is one data member, integer I, in superclass 1. There is another superclass 2, which also has integer I. Now, if subclass derives from both the superclasses, now there are two data members inherited by this subclass, both with the name I. Okay, this type of ambiguity can occur whenever you try to implement multiple inheritance. Okay, similar ambiguity will occur when you try to invoke a method using object of subclass which inherits properties from multiple superclasses. Okay, so in order to avoid all those ambiguities, Java has a restriction that you cannot implement multiple inheritance using class. Java has an alternate approach that we'll see in detail. Java has an alternate approach called interface. So multiple inheritance is not as it is supported by Java using concept of class, but indirectly Java supports multiple inheritance with the help of concept of class and interface. Okay, so that we'll see later, but directly with the help of concept of class, you cannot create a class from multiple superclasses in Java. All right, fine. Diagrammatically, teaser relationship can be shown like this. I can say that shape here is a superclass. Circle extends shape because circle is a shape. Rectangle also extends shape because rectangle is also a shape. So there is a relationship as we discussed. Circle is shape. Similarly, rectangle is shape. But I can say that square is a more specific form of rectangle such that both the sides are equal. Okay, both the sides are equal. So I can say that square is a rectangle. Okay, now this type of inheritance is called, like, it is basically single inheritance only, because as you can see, if you create square class, it is extended from which class? Rectangle class. If you create rectangle class, it is extended from which class? Shape class. Similarly, circle class, it is extended from shape class. Means that every subclass in this diagram is extended from only single superclass. So this is basically single inheritance only. But since it forms a kind of tree structure, hierarchy, it is also called hierarchical inheritance. Okay, but as I say, it is basically created from single inheritance only. In the entire diagram, there is no subclass which is created from multiple superclasses here. All right, so it is not the case of multiple inheritance at all. All right, now the general syntax to create any class from a superclass is like this: class, the keyword, name of the class, say for example here circle, extends existing class name, say for example shape. So I can write here class circle extends shape. Member list, okay, obviously I will put shape has a common property called area, okay, because every shape has area. But what is more specific to circle? Circle has a center, circle has a radius value. Okay, similarly, rectangle, I can write class rectangle extends shape. What member I will put in rectangle? Again, rectangle also has area because it is also a shape. Okay, but it has specific features, it has a length and breadth. All right, fine. So in this way, you can create a subclass from some existing superclass. All right, fine. Let us move further. Okay, so when I say that class circle is derived from class shape, it is written like this. I just said right now, public class circle extends shape. Okay, the more like advantage, apart from good logical structure, the advantage is code reuse. Whatever you have coded inside shape is now readily available to circle. No? Okay, what you have to write here in the circle class? Only thing which is specific to circle. The general thing which belongs to shape class is already available in circle because it is extending the capabilities of shape. Okay, so the basic advantage of inheritance, general functionalities can be written once and can be applied in any subclasses. So once whatever is general to shape is specified in the shape class, now it is readily available to all the classes, like it is available in circle class, it is available in rectangle class, and through rectangle class, it is also available in the square class. Okay, so you write only once the general things, and then you can use it in all the subclasses. That is called code reusability. Okay, the subclasses can specialize by adding members and methods, and even they can override the methods. Okay, now that we'll see in more detail how to override a method. And what is method overriding? Okay, subclasses have all the data members and methods of the superclass as we discussed, and subclasses can add to the superclass additional data members and additional methods as I just explained. Subclasses are more specific and have more functionalities. Okay, because subclasses are extending the superclass, they have more functionalities. Superclass capture generic functionality common across many types of objects. All right, fine. So this is already understood very well, I guess. Okay, overriding. Now, what is overriding? A very important concept. Okay, let's say there is a superclass, and in this superclass there is one method. Okay, now when I create object of this superclass, and if I invoke the method, naturally that particular method will be called. Okay, now I am creating subclass, and in the subclass, I am writing the same method again. Try to understand. There was a superclass and there was a method in the superclass. When I create object of the superclass, and if I invoke the method using object of the superclass, it is very like natural that method of the superclass will be called. Now I am creating subclass from that superclass, and in the subclass, I am writing the same method again with the same name, with the same return type, with the same number of parameters, technically calling with the same signature. Okay, now this is called method overriding. Okay, if you remember in session 1, we talk about constructor overloading. Okay, should not be confused between overloading and overriding. Okay, that time we clearly discussed that if you write the same method within a class multiple times, then it is called method overloading. And we took an example of constructor overloading because we wrote default constructor or zero argument constructor. We also included one argument constructor, two argument constructor within the class. So the constructor was defined multiple times within the class. So that was the concept of that was the concept of method or constructor overloading. Okay, whereas now we are talking about overriding. I'm not writing the same method multiple times within the class. Rather than that, I am writing method in the superclass and the same method again in the subclass. So methods, they exist in two different classes. Okay, once in the superclass and once in the subclass. So whenever you redefine the method which is present in the superclass in the subclass, then the concept is called method overriding. Okay, so sometimes people get easily confused between the concept of overloading and overriding. Again, I repeat in brief, in overloading, same method is defined multiple times within the class. Okay, whereas in overriding, same method is defined in the superclass and in the subclass. All right, fine. So let us see what happens when you override a method. Okay, a subclass can override means redefine the method present in the superclass. Okay, now what will happen? Okay, now what will happen if I create object of the subclass? Subclass has method of the superclass available plus its own method available. The problem is what? Method is having same name, same signature. Okay, so same method is available in the subclass two times. Once it has derived from the superclass and another its own copy of that method, its own version of that method. Now, when I create object of the subclass, and if I invoke the method, which method will be called? From subclass or from superclass? Okay, so what compiler will do? Objects of the subclass will use the new method. New method means the subclass version of the method. Okay, because name of the method is same, signature is also same. So when I create object of the subclass, and if I invoke the method, which method will be called? The method which is present in the subclass, or more technically I say, when I use object of the subclass to invoke the overridden method, the subclass version of the method will be called. But if I use object of the superclass, then original version will be called. Original version means the superclass version of the method will be called. So remember this very, very well. I repeat, remember this very, very well. Whenever method is overridden, for subclass, there is only one version. But for the, for superclass, there is only one version. But for the subclass, there are two versions of the method. One of the superclass and another its own version. So if I create object of the subclass and if I invoke the method, then subclass version of the method will be called. But if I create object of the superclass and if I invoke the method, obviously it will call the superclass version of the method. All right. What is the actual use? Okay, that we'll see later on. Let's say there is a class rectangle, which is a superclass. Assume that class rectangle is a superclass, which has one method called area. What this method is doing? This method is calculating the area of rectangle, that is length into width, and it is returning that particular area. Okay, this is simple method. It calculates area of rectangle and it returns the area. Now consider that there is another class called box. Okay, I have not followed the entire syntax. I'm just saying there is a class called box, which is subclass of rectangle. Okay, now what is specific to box? Box has a length. Yes, it has. Box has a width. Yes, it has. What is more specific to box? Box also has height. Okay, rectangle has length and width, but box also has height. Okay, it is a three-dimensional shape. So can you calculate area of box? You can calculate volume of the box. You can also calculate surface area of the box. So if you want to calculate surface area of the box, because box has common properties like rectangle, length and width, it has only one specific property called height. I can very well create box class as a subclass of rectangle, and in the subclass box, I want to calculate area of box. So I will again write the method. Look at the method, public double area. This is also public double area. This area method is in the superclass rectangle, and this area method is in the subclass box. This is called method overriding. This is signature. This is signature. Return access specifier, return type, methods name, parameters. All the things are same here. Public, double, area, no arguments. Okay. Now, because box is a subclass of rectangle, it extends rectangle class, and this method is also available to box. This method is also available to box. But calculation of box area is slightly different. It is using this equation. Okay. Now, if I create object of rectangle class, okay, suppose if I write rectangle R1 is equal to new rectangle, and if I call R1 dot area, this method will be called. Okay, applying this logic, object of the superclass will use original version. This is original version of area method. So if I create object of rectangle class, rectangle R1 is equal to new rectangle, and if I say R1 dot area, this method will be called. Okay, but what if I create object of the subclass? If I say box B1 is equal to new box, and then if I write B1 dot area, there are two areas available. This is also available in box class, and this is itself also available in the box class. But because it is object of the subclass B1 dot area, and because B1 is box object, this area method is called. All right, this area method is called. Fine. So whenever method is overridden, and if you use object of the subclass to invoke the method, the subclass version will be called. If you use the object of superclass to call the method, then superclass or the original version of the method will be called. Okay. Can you prevent this from happening? Yes, there is a way available in Java called final method. Okay, if particular subclass, if particular superclass decides that my particular method, one of my particular method, cannot be overridden by any particular subclass. So if particular superclass decides that one of my particular method must not be overridden by any subclass, then it can declare that particular method as final method. Okay, can declare a method of a class final using keyword final. So there is a keyword called final. If you put this particular keyword final in the beginning of the method, okay, then that particular method cannot be overridden by the subclass. If subclass tries to override that method, it will generate compilation error. Program will not be compiled. Okay, you can write like this: public final void do something. Okay, the keyword final is important here. Now, if this method is declared, as you can see here, as using final keyword in this particular, whatever the class may be, any class which is a subclass of this particular class cannot override this method do something. Okay, because this class has declared method as final. Okay, this is method's body. Okay, if a method of a class is declared final, it cannot be overridden with a new definition in the derived class, as I said. Okay, fine. So there is a way to prevent method overriding. Okay, but method overriding has one very specific requirement, very specific usefulness, and that's why method overriding is available. Okay, let's see why method overriding is useful. In what sense? Okay, calling methods of the superclass. Okay, now as we just discussed that method is overridden, and if you use subclass object to call the method, always the subclass version of the method will be called. What if I want to call superclass version using object of the subclass? Is it possible? That is also possible. Okay, so Java programming language has like provided all the features. So if you create object of the subclass, and if you call the method, you know that the subclass version will be called. Then how to call method of the superclass using object of the subclass? There is a way using super keyword. Okay, to write methods definition of a subclass, specify a call to public method of the superclass. Okay, so we require super keyword. Okay, like this: super dot method name in the bracket parameter list. Okay, if subclass does not override, then we require simply methods name. Okay, so from any method of the subclass, whether it is overridden or it is not overridden, from any method of the subclass, you can always call method of the superclass. If method is not overridden, you have to just write method's name and write the parameter. Okay, this method from the superclass will be called if method is not overridden. But if method is overridden, like area in our example, then you have to write within area. If at all you want to call area method of the superclass, you have to write super dot area, and you can pass the parameters. Okay. Same is applicable to constructor. Constructor is also method. Okay. So as we discussed in session 1, constructor is used to initialize data members of the class. Now consider that I have created rectangle class. Rectangle has data members, length and width, and there is a constructor which is initializing this data member. Now I'm creating box class which is extending rectangle with a specific data member height. Now I write a constructor in the box class. Okay. Now the problem here is, can you override a constructor? No, you cannot override a constructor. Why constructor cannot be overridden the way method can be overridden? Okay, because the constructor has to have same name as the class name. So the name of the constructor in the rectangle class is rectangle, and name of the constructor in the subclass box is nothing but box. So when I create object of the box class, it has total 3 data members: length and width derived from rectangle class, and height, which is available in the box class. But the problem is what? In the constructor of box subclass, I can initialize only the height of the box. What about the length and width of the box? How to initialize them? So I require to call constructor of the superclass rectangle from within constructor of the subclass box. How to do that? Again, with the help of keyword super. Okay, so super keyword can be used in 2 different ways. Super keyword can be used to invoke method of the superclass. Similarly, super keyword can be used to call constructor of the superclass. Let us see how to do that. Okay, it has to be the first statement. See here, public box. This is what? Public box is what? Public box is a constructor in the subclass box which can initialize height of the box but cannot initialize length and width of the box. For that you require constructor of the rectangle class, which is superclass. So what I will do? I will call super empty brackets. What will happen from here? From here, the rectangle class constructor will be called, and from within that superclass rectangle constructor, the length and width of the box will be initialized. And then here, I will initialize height. In this way, all the 3 parameters of the box are finally initialized. Okay, try to understand what happened in this small code. When I create object of the box class, which is subclass of rectangle class, I have total 3 things to be initialized for box: length, width, and height. Okay, so when I create object of the box class, this constructor is called automatically. We know that constructor is called automatically. When this constructor is called, it can initialize height, but it cannot initialize length and width. For that, you require constructor of the superclass, which can initialize length and width. So what I'm doing from here, from within the subclass constructor box, I am invoking superclass constructor. So what I have to write? Super keyword empty brackets. So from here, 0 argument constructor of the superclass is called, which will initialize length and width of the box. And then control will come back here, and then I'm initializing height of the box. Okay, remember, this must be the first statement. I cannot write height is equal to 0 first and then call superclass constructor. I am supposed to call superclass constructor first, then and only then I can do anything here. As you can read here, must be the first statement. This statement has to be first. After that, you can write whatever you want to write in the constructor. Okay, I can also specify parameters. Okay, now here what is happening? Length, width, and height, they are all initialized to 0. What if I want to initialize them to some other value? Okay, so we know that parameterized constructor is possible. Parameterized constructor is possible. Okay, so now let us look at the parameterized constructor. This is parameterized constructor of the subclass, where I'm passing length, width, and height, L, W, and H, using which I will be initializing length, width, and height of the box. But the problem, same problem occurs here again. I can initialize height to H. Just like this, height is equal to 0, I can write here height is equal to H. But what about length and width? For that purpose, I require 2 argument constructor of the superclass. So what I'll be doing using super keyword, I will call two argument constructor of the superclass. So from here, two argument constructor of the superclass will be called, where I am passing length and width from here, which will initialize length and width of the box. Control will come back, and here I will initialize height of the box. Okay, so using this super keyword, I am able to call superclass constructor like this. All right, fine. Now let us look at the actual usefulness of that method overriding. Okay, why method overriding is available and why to override a method. Okay, so the reason is polymorphism. In session 1, we discussed in very brief what is polymorphism. Polymorphism is nothing but same name used for multiple forms. Okay, same method name, but there are multiple forms. Okay, and different forms will be used at different location in different situations. Okay, so it is implemented with the help of concept of late binding, dynamic binding. Okay, these also we discussed in session 1. What is late binding? What is dynamic binding? So we discussed that whenever message is passed to the object, using dot operator, object will find out appropriate method from within the class, and whichever method matches the signature, that particular method will be called. And this decision is taken at runtime, not at compilation time. So this is known as runtime binding, also called dynamic binding, also called late binding. So which method to be executed is determined at execution time and not at runtime. Okay, not at compilation time. So this is called late binding. Okay, so polymorphism is nothing but to assign multiple meaning to the same name, or multiple forms, name is same. Okay, so now let us look at how exactly polymorphism is implemented. So you require, if you want to implement polymorphism, you require multiple concepts. First of all, you should know the concept of late binding, you should know the concept of inheritance, and you should know the concept of method overriding. Okay, I repeat, if you want to implement polymorphism, you should know the concept of late binding, you should know the concept of inheritance, and you should know the concept of method overriding. After knowing all these concepts only, you can implement polymorphism. Okay, so the reference variable of superclass can point to any object of superclass or the subclass. Read this statement 3 times, 4 times, 5 times, as many times as you want. Until you understand this statement, polymorphism cannot be understood. Okay, reference variable of superclass can refer to object of superclass or object of subclass. This is very important statement. This particular concept we have not seen so far. Whenever we create, whenever you declare a class, you always create reference variable of that particular class. Okay, say for example, complex. If you remember from session 1, we created complex class to represent complex number. Okay, so I create complex C1, C2, C3. So there is a complex class and I'm creating references also of the complex class only. Okay, but when we have inheritance implemented, we have a superclass also and we have a subclass also. So I can create reference variable of superclass also, I can create reference variable of subclass also. But the twist is here, when we have superclass implemented and subclass implemented, and when you create reference variable of superclass, that reference variable of superclass can refer to object of superclass also and can refer to object of subclass also. Okay, these reference variables have many forms. That is, they are polymorphic reference variables. Polymorphic reference variables means that a reference variable which can refer to objects of different forms. That is superclass object also and subclass object also. Two different forms of object can be referred by same reference variable, and such reference variable is called polymorphic reference variable. Okay, they can refer to object of their own class as well as object to the classes of the that is inherited from their class. In other words, whatever I said just now, they can refer to object of their own class, that is the superclass, and objects of the subclasses as well. Okay. Okay, consider this particular diagram. We have already seen this shape, circle, rectangle, and square. Now we are going to see polymorphic reference variable and polymorphism with the help of that concept. Okay, now see here, shape, my shape. Okay, shape, my shape. That is, my shape is reference variable of shape class. That is superclass. Is equal to new circle. I'm creating object of the circle class. Okay, so circle object is created, but reference is given to superclass variable. Reference is given to superclass variable. This is allowed. This is allowed because, as we discussed just now, this is polymorphic reference variable. This is variable. This is reference variable of superclass. It can refer to superclass object, that is shape class object, as well as it can also refer to subclass object, that is circle object or rectangle object or even square object. Okay, so shape, my shape is equal to new circle is allowed. I repeat, object of circle class, which is subclass, is created and reference is made available to reference is stored in superclass reference variable. Okay, now when I say my shape dot calculate area, my shape dot calculate area, this will call method of circle class. There has to be method calculate area in circle class. So when I say my shape dot calculate area of circle class will be called. Okay, now look at the next statement. Shape, my shape 2 is equal to new rectangle. This time I am creating object of rectangle class, which is another subclass of the shape. And I am assigning reference to the reference variable of shape. So now again, another subclass object is created whose reference is stored in the superclass reference variable. And now using this superclass reference variable, if I call calculate area method, this time it will calculate or it will call calculate area method of rectangle subclass. Okay, in both the cases, the reference which is used is of shape only. Reference which is used is the shape only. But when you call the method using superclass reference, I repeat, when you call the method using superclass reference, which method will be called depends upon it is referring object of which subclass. This is slightly difficult statement to understand. I repeat, whenever you call method using superclass reference, that time which method will be called depends upon which subclass object it is referring. In this statement, my shape is superclass reference variable dot calculate area will call calculate area method of circle, because at that point of time superclass reference variable was referring to subclass object circle. Now my shape 2 dot calculate area, this time calculate area, this will call method calculate area of rectangle, because this time this superclass reference variable is referring to object of another subclass rectangle. Okay, so this method calculate area here and this method calculate area here, they have same name, same number of parameters, but this time here it is calling calculate area from circle, and this time here it is calling calculate area from rectangle. Okay, so whenever you call a method using superclass reference variable, which method will be called depends upon it is referring to which subclass object, circle or rectangle. In fact, here I've used my shape 2. Even if I use my shape again here, okay, and not a different variable, even it is my shape only without a different reference variable, even then it will call calculate area from rectangle only. Okay, now let us see what is not allowed. Rectangle class. Okay, rectangle class. I'm creating reference of rectangle class. Okay, my rectangle class. Okay, and if I try to create object of shape class, which is superclass, so object of superclass cannot be referred by reference variable of subclass. I repeat, object of superclass cannot be referred by reference variable of subclass. This is not allowed. This will generate compilation error. Okay, so what is polymorphism in this particular small piece of code? Polymorphism is here. Calculate area, from here it is calling method of the circle class, and calculate area again I'm saying from here it is calling method of the rectangle class. Okay, so circle class also has calculate area method, rectangle class also has calculate area method, but when I'm using superclass reference variable, whether this will be called or this will be called, that depends upon superclass variable is referring to circle object or rectangle object. So these two versions are called using superclass reference variable. It is decided whether this version will be called or this version will be called dynamically at runtime, dynamically at execution time, depending upon superclass reference variable is referring to this class object or this class object, appropriate version will be called. That is polymorphism. Multiple forms, same name. Multiple forms, same name. Which form to be used at runtime depends upon you are referring to object of which class, this subclass or this subclass. Accordingly, appropriate version will be called. Okay, you cannot try to do reverse string, that is object of superclass and reference of subclass is not allowed. Okay, this is compilation error. All right. Okay, now that was about polymorphism. Whenever you implement polymorphism, let me go back to the previous diagram. Here I said calculate area of this class will be called, calculate area of this class will be called. What if I have calculate area present in the shape? Can you have calculate area in the shape? Can I calculate area in the shape class? No, you cannot calculate area in the shape class. Why? Because if you want to calculate area, you require some parameter. You require either length, width. Okay, you require either radius. Okay, shape doesn't have any specific characteristic. Shape has only area. Shape has only area, but there is no way to calculate area. There are no parameters to calculate area. So even if I put calculate area method in the superclass shape, I will not be in a position to calculate area. Okay, so what I will do, try to understand, listen carefully what I will do. I will have one data member in the superclass shape called area. I will also have a method calculate area in the superclass shape, but since it is not possible to calculate this area here, I will declare this method as abstract method. I will declare this method as abstract method, and then implementation of that method will be available in circle class and will be available in rectangle class, where it is actually possible to calculate area, because now circle has a radius available. Using pi r square, now I can calculate area. Here length and width is available. Using length into width, I can calculate area here. Okay, so the concrete version of calculate area is available in circle. and concrete version of calculate area is also available in rectangle, but a vague implementation, or uh, you can say an abstract version, a vague version of calculate area is available in the shape class, and that is called abstract method. Okay, so what is abstract method? A method that only has heading with no body. As I said, as I just gave you example, I can put calculate area method in the shape class, but how will I calculate? I don't have any parameters to calculate. So I will create a method. I will specify its access specifier. I will specify its return type. I will specify its name. I will specify its parameter, if any, but I will not specify its body. Okay, why I will not specify its body? Because this superclass, this general class is so general that it has no specific details available to implement that method. Okay, so philosophically, I can say that the superclass is so general that it doesn't have any specific details available to implement the body. Okay, so if I again go back to the example of shape, circle, and rectangle, if I put calculate area method in the shape class, I will write public double calculate area empty brackets. Now what? How will I calculate area? I don't have anything to calculate area. So I will not have any body. But now I go to circle. I will put public double calculate area empty brackets. Can I calculate area now? Yes, I can write pi r square because radius is available in circle. Similarly, in rectangle class, again I will write public double calculate area empty brackets. Can I calculate area here? Yes, I can. Area is equal to length into width. Okay, so what is about the method which I put in the shape class? Public double calculate area empty brackets. I don't have any specific details available to implement that body. So I will write the method, but no body of the method. Such method in the superclass is called abstract method. Okay, so if someone asks you, what is abstract method? Abstract method is a method in a superclass which has no implementation, which has no body available, but it has only signature available. Okay, fine. So such method is called abstract method. Okay, must be implemented in a subclass. Okay, now the question is, I have included calculate area as an abstract method without body in the shape class. Now I am creating subclass circle. Again, I will put calculate area here as abstract method without body. Even though I am capable of calculating circles area, what if I don't write implementation of calculate area here? Then it is an error. Then it is an error. Subclass has to implement abstract method of the superclass. I repeat, subclass has to implement abstract method of the superclass. So when superclass says that calculate area is my abstract method, the subclass circle has to implement calculate area using its body, that is pi r square. Rectangle class also has to implement its body using length into width. They can have different implementation, but implementation is a must, or can be either declared as abstract. Then there has to be subclass of circle. Eventually, somehow you have to implement abstract method. So once a particular method is declared as abstract in one of the superclass, either it is implemented by the subclass of that superclass, or subclass again says it is abstract method, then subclass of the subclass has to implement the method's body of the abstract method. Okay, so it has to be implemented somehow. It has to be implemented by some subclass somehow. All right, fine. Now any class which has one or more abstract method is called abstract class. So there is a concept of abstract class. What is an abstract class? Abstract class is a class which is declared using reserved keyword abstract. There is a keyword called abstract in Java. And if you put abstract keyword in the front of the class name, then the class is called abstract class. An abstract class can have instance variables, constructors, final methods, final constants, and even non-abstract methods, but will have some abstract method also. Okay, so an abstract class can contain abstract methods. An abstract class cannot be instantaneous. Okay, cannot be having object of itself. Okay, because it has one or more abstract methods, and because abstract class has one or more abstract methods, the complete implementation is not available. And because complete implementation is not available, I cannot create object of abstract class. Okay, a class with at least one abstract method must be declared as abstract class. So if you have at least one abstract method, you have to declare that class as abstract class. You can create object of subclass of an abstract class, but if and only if they give definition of all the abstract method of the superclass. Otherwise, again, you have to declare subclass as an abstract class, and you cannot create object of even that subclass also. All right, fine. So that is the concept of abstract class and inheritance and method overriding and polymorphism. Okay, now in all this chaos, hopefully you have understood the entire chaos properly. In this entire chaos, what about multiple inheritance? In all the examples that we have seen in method overriding and everywhere, we have only seen the simple and single inheritance. Okay, multiple inheritance, as we discussed, it is not possible to implement multiple inheritance using the concept of class in Java. Okay, so what if you want to implement multiple inheritance? You require to use a concept, you have to use the concept of interface. Okay, so Java has a concept of interface. Let's see how to create interface and how to use interface. It is similar to class, but with so many restrictions. It has only abstract method, nothing but all the methods that you declare in an interface cannot have implementation, cannot have their body. They are all abstract method. They all will have signature without body. At the same time, all the instance variables that you declare in the interface are all final and constant. You cannot modify their value. Okay, so all the instance variables are constants, and all the methods that you declare in interface are also abstract methods. Any number of classes can implement an interface. Once the interface is created, you can have n number of classes implementing that particular interface. See the word implement here. When we use inheritance, we use the word extend. We say that subclass extend the superclass. But here we are not calling extend keyword. We are saying implement. Why we are saying the word implement here? Because any class that implement an interface has to provide implementation of all the abstract methods. And that's why we say that class implements interface, and not, it is not extending anything. It is implementing all the abstract methods of that particular interface. Okay, so one class can implement any number of interfaces, and that is how it allows multiple inheritance also. We'll see in more detail. To implement an interface, class must define a method declaring the interface. Each class also has its new features. So it is something like inheritance only, but the restriction is what? When a class implement a particular interface, it is necessary that class has to implement all the abstract methods of that interface, can have its own methods also. Okay, so let's say how to define an interface. General form of defining an interface is like this. Access specifier, okay, normally it is public or default. Interface is a keyword, name of the interface. Just like class is a keyword, interface is a keyword and name of the interface. Then you have to define return type, method name, parameter list, semicolon. No methods body. No methods body. You can define n number of methods, but all the methods will be abstract like this. You will have method signature, but no implementation. Okay, method 2, method 3, method 4, any number of methods. Okay, similarly, variables, that is instance variable 1, you have to declare as final because it is a constant, you have to specify value. It could be integer, it could be float, it could be double, it could be anything, but it has to have a value and it is by default final. Even if you don't write final keyword, it is understood that it is final because it is a part of interface. Okay, another variable, it may be static, okay, but again, it is final, it is constant. Okay, this is general form of interface. Okay, an example, interface. Okay, interface. So what is access specifier of this interface? It is default access specifier. It will be visible only within the package, just like class. It is not available outside the package. Okay, the interface name is callback. There is a method called void callback, and there are parameters. As you can see, there is no method body. Okay, and there is no constant available here. Okay, so it is a very small interface with just one method callback. Okay, now how to access particular interface? So they are all final static. Variables must be initialized to constant value. They are implicitly public. Okay, so the general syntax to implement particular interface, the access specifier of the class, again, either public or default. Class, name of the class, extends some superclass possibly, implements one or more interfaces. Okay, so class can extend from superclass, at the same time can implement interfaces. Okay, so this is how multiple inheritance is possible. Your class is extending superclass and implementing other interfaces. Okay, so let us take an example. Okay, this is the example. Interface call, void callback, integer parameter. Now there is a class called client which implements this particular interface. Client implements call. Now, because it is implementing this particular interface, it has to define this method's body. So it is public void callback integer p. This is integer parameter p. Okay. Method's name is same, return type is same. Okay, access specifier can be default or public. System.out.println callback with p. Okay, similarly, now public class test, what I'm doing, how do I access this particular method? See the way I'm accessing method, public static void main. I am creating reference of the interface. See, I'm creating reference of the interface. Call C. C is a reference of this interface. Okay, but I cannot create object of this interface because it is like all abstract method. I cannot create object of interface, just like abstract class. But I can create object of client class, the class which is implementing this method, which is implementing this interface and implementing this method. Okay, so new client, I have created object of the client class and reference is assigned to the interface reference variable. And when I say c.callback, this callback method will be called. Okay. Another example, interface call, where there is a abstract method callback. Now I have two classes. Class client implements callback method, like previous case. There is another client class which also implements the same interface. So it has again the same method, callback. Okay, system.out.println. Okay, this is from another client. This is from client. Now what happens? What happens? How the polymorphism is implemented here? I create I create interface reference variable called C is equal to new client. New client is object of this particular class which implements this interface. And when I say C.callback, this callback is called. Okay. Now when I say C is equal to new another client, object of this class is created, reference of the interface, same reference. Okay, C is reference of interface. And when I say C.callback, this time this callback is called. Okay, so this is again kind of polymorphism only. This is a kind of polymorphism only. Same name, two different versions, this version and this version. Whether this version is called or this version is called depends upon interface reference variable is referring to object of this class which implements interface or object of this class which also implements the same interface. All right, so this is polymorphism only. Okay, fine. Now, this is multiple inheritance. See interface test 1 and interface test 2. There are two interfaces, test 1 and test 2. Okay, they both have same variable, rather say same constant, value 10, value 20, and same abstract method for void display. Now, if class implements both the interfaces, it has two constants with the same name, val. It has two abstract methods to be implemented, display. Okay, so now in this particular class which implements both the interfaces test 1 and test 2, public void display. Okay, how will I access this constant variable? Okay, test1.val and test2.val. Okay, so because there is ambiguity, same constant is available in both the interfaces, I require to resolve this ambiguity with the help of interface name dot constant name. Okay, so whenever you try to implement multiple inheritance, this type of ambiguity is going to occur. Okay, fine. So that is all about the concept of inheritance, overriding, polymorphism, interface, and multiple inheritance. Okay, so now we quickly go through the concept of exception and errors in Java. Okay, that is another way to implement a new concept called exception handling in Java. Okay, fine. So what is exception? What is error? When a problem encounters an unexpected termination due to some fault is called exception. Okay, so program is under execution and all of a sudden some unexpected error occurs and program terminates abruptly, then this is called an exception. It is an exceptional situation which has arisen and which makes program to terminate. Okay, let's say we have some arithmetic expression and due to some mistake, we perform divide by 0. And as soon as divide by 0 happens, it is not possible to divide any number with 0 and it is unexpected situation and your program will terminate abruptly. Okay, so exception handling will give us another opportunity to recover from that abnormal situation. Okay, so you try to divide something and because of some mathematical expression in the denominator 0 occurs and abnormal situation arises. If you do not handle it, your program will terminate abruptly. Exception handling will allow you to handle this particular abnormal situation. It gives you an opportunity to recover from this abnormal situation. Okay, and your program will not terminate abruptly, but it will continue as if nothing happened. Okay, so exception handling will allow you to will give you opportunity to continue with the program execution even though some abnormal situation occurs. So that makes Java program robust. Okay, we say that Java programs are robust. So why and how Java programs are robust? Because this type of abnormal situation, which otherwise would result in abnormal termination, can be handled with the help of exception handling mechanism in Java. Okay, so sometimes we might encounter situation where like out of memory or some problem with virtual machine. Okay, system runs into deadlock situation. Okay, so in this case we cannot like do much, and this type of abnormality is called error. Okay, so error and exception both are almost similar, like runtime abnormal situation, but in the case of exception, you can handle it and you can recover from that error. But sometimes error like out of memory or deadlock kind of situation where from within program you cannot do anything. Okay, so that type of abnormal situation in Java is called error. Okay, so this is complete hierarchy of classes. As we all know, object is the superclass of all the classes in Java. So this is superclass object. Throwable is a subclass of object, and from throwable, two subclasses are created: error and exception. Okay, these are all predefined. These are all predefined classes. Okay, this is exception class and this is error class. So as we just discussed, what is the difference between error and exception? Exception is the abnormal situation occurred at runtime and which is possible to handle and can be recovered from it. Whereas in the case of error, an abnormal situation has occurred at runtime and nothing much can be done from within the program apart from like saying user that regret to have this type of situation and gracefully terminating the program. Okay, because nothing much can be done from within program if your system runs into deadlock situation. Okay, fine, but exception is a kind of abnormal situation which can be handled like divide by zero. Okay, and we can recover from within the program and program will continue execution. So in order to support all this, Java has a rich set of predefined classes. The entire hierarchy can be seen here. Okay, fine. Now this runtime exception is a specific kind of exception. Okay, we'll see slightly into more details of this. Okay, so this is entire class hierarchy available for exception handling mechanism. Okay, so we'll be mainly focusing on this part. We'll be mainly focusing on this part. All right. So there is something called checked and unchecked exception. Okay, what is checked exception and what is unchecked exception? So when you compile your program, your Java compiler is little more, you can say, vigilant. It is more vigilant in a sense. It will keep on checking for the code which is prone to generate error at runtime. Okay, try to understand. Try to understand. Your Java compiler is more vigilant in a sense that when you compile your program, it will look for the code which is prone to generate error at runtime. And such exception must be handled by program. Java compiler says that this particular code is prone to generate runtime error and you are supposed to handle the situation within code only. Such exceptions are called checked exceptions. Okay, but there are certain exceptions which cannot be checked, which cannot like Java compiler be sure about, like divide by zero. So when the program is under compilation, Java compiler cannot find out what will be the expression value in the denominator which will result in zero so that divide by zero will occur. it is not possible to determine at compilation time that denominator expression will result into 0 and that will give rise to divide by 0 error. Okay, so such exceptions are called unchecked exception. Java compiler cannot say at compilation time that you have to catch this exception. Okay, because it is not possible to determine at compilation time whether this particular code may generate error or will not generate error. All right, so there are two types of exceptions, checked exception and unchecked exceptions. Okay, so exceptions which are checked at compilation time are called checked exception. As I said, like input output. Okay, you are trying to read something from the file. And what if file does not exist? Okay, so this is quite possible situation. So Java compiler says that whenever you try to open a file, whenever you try to read the file, the related exception you have to handle within the code only. You are supposed to do that. Okay, otherwise compiler will generate compilation error. Okay. Okay, like you are trying to perform some SQL, you are interacting with the database. Okay, you are interacting with the database, and what if database returns some wrong value or database says that particular column not found? So you should be ready here in your code to catch that particular mistake. So compiler says that you are supposed to handle this particular exception, otherwise it results into compilation error. Okay. Exceptions which cannot be checked at the compilation time are called unchecked exception. Okay, so as I say, null pointer exception, or as I said, divide by 0 exception, or you can say array index out of bound exception. Okay, so at compilation time, it is not possible to find out for a compiler that when you write some array name in square bracket some expression. Okay, you have declared one array. Let's say this array is of size 10. You are trying to access particular element. So you are writing array name in square bracket, some expression. Now compiler cannot find out at compilation time that this expression will result in some integer value which is beyond the size of array. Okay, so such error, such exception cannot be checked at a compilation time. Okay, so this type of exceptions are called unchecked exceptions. Okay, all checked exceptions must be handled in the program. As I said, this type of exception, like you are reading some file or you are doing some SQL operation, compiler says that you are supposed to handle them in the program. If the exception is raised and it is not handled, then it is finally given to Java Virtual Machine. Okay, JVM, and JVM will terminate the program and will display the entire exceptions value. Okay, fine. Now, how to catch an exception? Okay, so any code which you suspect, which is prone to generate error, you have to write that particular code inside try block. Okay, so when you say exception handling mechanism has total 5 keywords: try, catch, finally, throw, and throws. I repeat, exception handling mechanism in Java has total 5 related keywords. These keywords you should remember very well. Okay, can be asked during test, can be asked during interview. Okay, do you know the keywords related to exception handling in Java? Okay, so you should know. There are 5. Which are they? Try, catch, finally, throw, and throws. Okay, last 2 are throw and throws. Okay, so here we are using 3 of them: try, catch, finally. What is the purpose of try? The code which you suspect that it will generate error at runtime. Here you are trying to open a file and you are trying to read something from the file, input stream. You are trying to open the file and read from the file. But what happens if file does not exist on the disk? So in that case, this will generate file not found exception. So that error will be caught in the catch block. So as you can see in the catch block, file not found exception will be caught here, and it is giving you opportunity to open another file. Okay, so if error occurs here, if file does not exist, the control will be directly transferred to this catch. Okay, if file not found exception generated, control will be transferred to this catch block, and it is giving you opportunity to open another file and try to read from that file. If this exception was not thrown, then control will not come to catch. After that, it will directly go to finally. Okay, so if exception is thrown, if exception is generated, it will go to catch and then it will execute finally. If exception was not thrown, exception was not generated, skipping this catch, it will directly go to finally. In other words, whatever you write inside finally will always execute irrespective of whether exception was generated or exception was not generated. So I repeat, if exception is generated from try, it will come to catch, it will execute the catch block, and then finally block will execute. If exception was not generated, file was existing, it is able to read from the file, there is no runtime problem, so it will not throw the exception, and because exception was not thrown, the catch block is skipped and control directly comes to finally after executing try block, and whatever is written inside finally will execute. So in either case, whether exception is thrown or exception is not thrown, finally block will always execute. So what part should be written in finally block? The part that you always want to execute should be written in finally. Okay, so I repeat, try contains which block or try contains which code which is prone to generate error. Catch contains which code? The correcting code, the recovery code, like try to open another file and read is a kind of recovery. And finally contains which code? Finally contains the code which you always want to execute whether exception is thrown or not. All right, so that was about try, catch, and final. Okay, the same thing is explained here. Okay. What if method which is generating error exception but is not handling that particular exception? Okay, so in that case we can use throws keyword. Okay, we are going to see all 5. As I say, try, catch, finally, throw, and throws. In the previous example, we have seen 3: try, catch, and finally. Okay, let us see the keyword throws here. So what is the purpose of throws keyword? When particular method is capable of generating error, that is exception, but is not handling that exception, then we have to specify the method throws exception. Okay, now try to see here. This is some method which is opening the file, which is trying to read from the file, but there is no try block. This particular code is very much prone to generating file not found exception, because whenever you try to open a file and when you try to read from a file, file not found can happen. So this particular method has a code which is very much susceptible, which is very much prone to generate the error at runtime, but there is no try block, there is no catch block here. Okay, means that this method is capable of generating exception, but is not ready to handle it. So what it will do? We will say this method throws file not found exception. Okay, what is the purpose of this? Whoever calls this method become vigilant that this method throws this exception. Whoever calls this method become vigilant and will know that there is a code inside this particular method which is capable of generating error, but is not ready to handle it. So who will handle it? The method which is calling it. So in this example, who is calling this method? It is called from here, from main method. So now main method becomes responsible for handling this error. So in general, remember, whenever any method is capable of generating error, but is not ready to handle that error, who becomes responsible for that error? The method who is calling that method. If that method is also not ready to handle, then who is responsible? The method which is calling that method, and so on. Ultimately, somehow, somewhere, that particular exception must be caught if it is checked exception. Something like this, file not found exception is a checked exception. So if it is not handled by this method, then it has to be handled by this method. If this is not main method and if it is some method and it is also not handling, then who will handle? The method which is calling this method. Somehow, somewhere it has to be caught. All right. Okay. So for that purpose, we require throws keyword to indicate that this method has a code which is capable of generating error, but the method is not handling. So whoever is calling this method will become ready to handle that exception. So that is indicated by throws keyword. Okay, the last one which is possible is throw. Okay, before we use the throw, one more point we have to see that you can catch multiple exceptions. Okay, fine. So this is an example. This code is similar to previous code. It is opening a file, trying to read. What is the very specific error? File not found exception. Okay, what is more general possible error? It is some IO exception. It is some input-output operation went wrong. File not found is very specific. What is more general thing? It is some IO error. Okay, program is trying to perform some input-output, but could not perform. It is some IO error. So this is a super class of file not found exception, IO exception. Okay, so if something else happened, file, okay, if something else happened, file found, but something else went wrong. So in that case, file not found exception is not thrown, then that something else can be caught here in IO exception. Okay, so some error related to IO, but not file not found exception can be caught here. Okay, so in this way, the code which is capable of generating multiple errors, you can catch them using multiple catch. So one try block may be followed by multiple catch, where generally the first catch is more specific and the later catches are more general. Okay, fine. So that is about catching multiple exceptions. You can create your own exception using exception class and using throw keyword. So we want to basically see the throw keyword. How to use throw keyword? Okay, so see here, class, my class extends exception. This is predefined exception class. This is my own class. It is extending predefined exception class. Now in my method, because of some error, if I want to throw exception, I can use the keyword throw. Throw new my exception. So in this particular small code, we are looking at two different things. First, throw keyword, and second, you can have your own custom exception also. Custom exception means no predefined exception is available, or no predefined exception is capable of handling the error which is very, very specific to your program. then you need to write your own exception. So you can write your own exception using this particular method, using this particular syntax. Write your class which extends exception class. Okay. And then you create object of your class which is extending the exception class. How will you generate, how will you throw this exception? Object is created. How to notify that this error is generated? So for that purpose, you can use throw keyword. So throw keyword is used to explicitly throw an exception, which is generally user-defined exception. Okay, so when you have user-defined exception, okay, because like divide by 0 or file not found, such exception is generated automatically by the JVM runtime. Okay, but the error which is very, very specific to your code that cannot be handled by Java itself, then you have to throw exception on your own. So create your own exception and throw it to notify that this very specific error has occurred. Okay, so with this, we come to end of exception handling. Actually, not end of exception handling. There are so many things, but we come to end of the session. We have seen all the 5 keywords, that is try, catch, finally, throws, and at the end this is throw. Okay, so with this we come to end of the session. Okay, so in this 3 days session, I tried to cover very basic fundamental things in object-oriented programming and more specific to Java programming. Okay, so specific to Java programming, like how to create class, how to create object, how to use arrays, how to create string, how to create mutable string, how to create vector, how to implement polymorphism, how to declare abstract class, how to call method from the super class using super keyword. So something very specific to Java is like super keyword. Okay, the abstract class, abstract keyword. Okay, and then this exception handling mechanism. Okay, Java is very, very vast and cannot be covered in 3 sessions. Okay, so this is just a refresher course where I try to give you very fundamental concepts of object-oriented programming and things which are very, very primitive, very, very fundamental to Java programming. Okay, so I hope this would have helped you to like brush up your memory, brush up your basic concepts, and so that you can explore Java and you can explore object-oriented programming in more detail as per your requirement, as per particular test requirement, or as per some specific interview requirement. Okay, so I thank you all so much for listening to me very patiently. I hope my sessions are helpful to you. In case of any particular queries, any particular doubt, or any particular question, if you have any difficulty or if you want to explore something, you can always reach out to me. Either you can always mail me on my official mail ID, which is vipul.dalal@vit.edu.in. Okay, so you can always contact me in case of any queries or doubts, not only related to object-oriented programming or not only related to Java, it may be related to any specific domain of mine, like databases, data warehousing, data mining, machine learning, image processing, computer graphics, and so on. I'm always available to all VIT students. Okay, so feel free to contact me. Okay, so with this, I close the session. I wish you all the very best for your interviews, for your tests, and for your future in short. Okay, fine. So I close the session. Thank you so much.